So I hope you guys have uh, gone through chapter 2 notes and also gone through um, the video link I put on Moodle. Basically, whatever is there on the chapter 2, it's already in the the link that I have provided, right? So this one is a WAN design. Okay, so chapter 3 will be talking about the WAN design. So basically, this note is about 46 page. So I won't go over everything in detail, but it's just the main points, and the others you have the notes and you can read on what is required, right? So the WAN design, you might, if you have read chapter 2, that was on with the LAN design. Okay, the aspects you needed for you to design a proper LAN. When your when your LAN is done, your local area network is done, then now you can go in with your planning your WAN, right? So the medium enterprise WAN design profile is a multi-site design where a site consists of multiple buildings and services. The sites are interconnected to various WAN transports as shown in figure 3.1. Okay. Yeah. So you have multiple LANs, okay, that all become your big WAN. Yeah. So you can see from you have the large building, medium building, small building, extra large, extra small building, your service block, your data center, okay, your UPF, okay. UPF is known as the quantum flow processor, okay, and then your internet edge coming down to your other various remote sites, okay. So all this becomes your big WAN. So WAN transport, okay, so this section discusses the different WAN transports presented in the WAN enterprise design profile. So private WAN service, the medium enterprise design profile consists of several locations. Okay, these locations have similar architecture as the main site. However, these sites need to collaborate with each other to meet the business objective. Therefore, a WAN network that can support the following requirements is needed. Okay, so it should be high performance, support different classes of traffic, native routing, multi-class capability, and should have proper security. What this is saying is, if you have a WAN, okay, here, okay, whatever services you have in each of the small LANs, okay, combine them, you should get your same quality of service, same quality of data transmission and security in all your small LANs as well. So collectively, they should be able to yeah, meet the business objectives, right? Say in banking, okay, you would need a very strong security, right? So that people are not able to hack and like can do some, okay, transfer money from here to there, or okay, do some scams or something. Okay, to support these requirements, enterprises need to have a private WAN service to provide connectivity between remote sites and main site, right? So internet service, okay, the physical uh, connection of reaching the internet and the private WAN network is same. However, but both circuits are logically separated using different sub interfaces. Okay, therefore, it is similar to a situation where a customer is connected to different service providers, right? So you have your private WAN, your internet, okay, Both come here, and then you have your site network. Then going to Metro service. Okay, so Metro Ethernet is one of the fastest growing WAN transport technologies in the telecommunication industry. The advantages of using this WAN transport are as follows. Okay, so you have scalability and reachability. Okay, services offered would scale from 1 Mbps to 10 Gbps, and service providers worldwide are migrating these networks to provide metro services. Okay, and performance, QoS, and suitability for conversions. I will not be reading all these here. Okay, you can do it on your own time because we just have 1 hour. So I'll just try to go over the main points only. And then you have cost saving. Okay, Metro Ethernet brings the cost model of Ethernet to WAN and expediting and enabling new applications. So there are two popular methods of service for Metro Ethernet. Okay, E-line, which is known as the Ethernet Virtual Private Network, EVPL, right, provides a point-to-point service, and ELAN, which provides multi-point or any point-to-point connectivity. Okay, leased line services. The WAN bandwidth requirement for a small route site is assumed to be 20 Mbps. Okay, Cisco recommends that the small remote site connect to the main site using a private leased line service. The leased line service are more reliable, available to these types of location, and the bandwidth is sufficient for the small remote site application requirements. Okay, here in VG we have I think one of the main uh, people who are giving leased lines are TFL. Okay, so if you go to their website, TFLPG, and businesses. Okay, so here they give so you get broadband, okay, for $49 a month, speeds up to 20 Mbps and one Mbps uploads. Okay. Four options to suit. So these are some of the options they give. Okay, so for a small business, this is what they recommend. Okay, for a small business that is running approximately about say you have what 5 users. Okay, so this should be sufficient. But yeah, if you need a bigger uh, bigger site, okay, like what we have on the campus, so that would require a bigger bandwidth, right? And these are the only people think they have lined network. As the other Vodafone and Digicel, they do not have line. Okay, it's all mostly wireless. And for home broadbands, they have they do have fiber. Fiber is not available everywhere. Okay, in India, I think it's just available in Denarau and Kennedy Avenue. You're living somewhere there. If you want, you can try fiber. Okay, and you have ADSL or VDLS. Okay, and then the 4G. So these are some of the plans people might look for when if they're not they are booking from home now, right? And also for businesses, basically when you lease lines, Okay, when you lease line, okay, you're not actually paying for the internet, but for the line, how fast your line is. The internet will come as a package to that line. So if you want a 10 Gbps line, so if they are selling, say, for example, $40 is 1 Gbps. I'm not sure of the price, I'm just saying, okay? $40 for 1 GB price. So if you want a 10 Gbps, so 40 multiplied by 10, so it'll be $400 monthly you have to pay for these lines, right? Well, in Fiji, before they used to pay so much, okay, for lines. Okay, you might know that all these companies, they buy lines from Fintel, and then from there they sublease it to Fintel sublease it to Vodafone in Digicel and TFL, and then from there TFL they sublease it to the companies, right? So before, I think they used to pay about, not sure, it was it was close to 400,000 or something, but that has not reduced significantly. Okay, yeah, okay. Before, they used to pay, companies used to pay $40,000, okay, $40,000 for a 10 Gbps line from Fintel, right? So if the TFL wants a 10 Gbps line, they'll pay $40,000 to Fintel. Now that has reduced to $640. So you can see the reduction, right? That is how the companies, we are now getting these so much data, and then it's for little, like so much data. You get about what, $8, you get 125 GB, something like that. Okay, so that is how we are getting that, because they, now the companies, they pay less. And that is how you might have heard, last year, when government, last year, before last year, government introduced that 10 cents per GB levy, and then the companies, they had said that um, they will absorb it. Okay, that is how they're absorbing, because now they have to pay less to Fintel, where they have more money. That is how they're able to absorb that 10 cents per GB from the customers and give us good line. Another thing on the uh, on that, while we are on the leased line, I think I did explain you about the Southern Cross cable, right? That is coming into Fiji. That is how we are connected to. While I am speaking, there is another line. Okay, there is Southern Cross Next Gen line coming up. All right. So this, if you see the screen, this was the old. We get a good picture. Right. This is the current I mean the line that we are using. Okay, the cables that we have at the moment. That is how there's another cable that is running like this. Okay, so it's coming from Los Angeles. So these are the two new nodes now connected with this cable. We have Tokelau and Kiribati. And in Fiji, we have 2 points. I think they're also connecting Vanuatu, right? So one line is going from Vanuatu, one is Viti and going to Sydney and Auckland, right? So these lines are, you guys want to see the pictures of how they are laying it? Yes, no?
Yes, sir. Yes.
Yes.
For that, I'll just have to open my Facebook, right? Because they had posted it on Facebook. If you're on Facebook, please do go and search for their page, Southern Cross Cable. So if you scroll down, so here you can see Farewell Beautiful Tokelau. They have done the cables there in Tokelau. Okay, and then this is the ship they're using to lay the cables. And then if you scroll down, this is in Kiribati, I suppose. Here, if you see this is in Savu Savu. They have set up the station. Yes, Southern Cross Cable Station. This is in Savu Savu. So now I think most of the parts in Vanwale, if you've been to Vanwale, they do not have 4G, right? Internet is quite slow compared to what we have here in Vitilevu. So with this, they should be with power to us. These are the cables that are running. So if you see the screen, this is how cables are run. Okay, you have thick fiber cables, and they go on the seabed. Yeah. So with this is more fast, right? Compared to what we have now. Just give me a minute. So the target is to complete it by Q1 2022. So next year, by the end of April, they should be able to finish it. Okay, so it's providing 72 terabyte per second plus. That will be the speed. We're not talking about gigabyte, we're talking about terabyte, 72 terabyte. So imagine if you have that, you're connected directly to that and you have to download a movie, how fast it'll download. You just blink and then 1 GB file will be downloaded like that. So that is some of the things, new things that is coming up. So with this, with the Southern Cross cable going like upgrading, we might be looking at very good speeds come next year in Fiji. Right. So when aggregation platform selection in the medium enterprise design profile. So in addition to selecting the WAN service for connectivity between remote site location and access to the internet, choosing the appropriate WAN aggregation router is essential. For each location in the medium enterprise design profile, various WAN aggregation profiles are selected based on the requirement. So main site WAN aggregation platform selection. A WAN aggregation router aggregates all the incoming WAN circuits from various locations in the network as well as the internet, and also provides the proper quality of service required for application delivery. Cisco recommends that the Cisco ASR family of routers as the WAN aggregation platform for the main site location. So you have some of the Cisco series router that are there that could be used with your WAN platform selection. Okay, when you're selecting your platform, mostly routers. Here if you get your line from TFL, most of the time they provide the router with the line. Yeah. So large remote site WAN aggregation platform selection. So the WAN connectivity between the large remote site to the main site is fairly simpler because of the lack of requirement of advanced encryption technologies. Therefore, the main purpose is to reduce the cost and try to consolidate the WAN functionality into the distribution service at the large site. However, at the large remote site, as per the LAN design document, VSS has been chosen as technology on the distribution switch. Right? So NVSS does not support WAN functionality. Therefore, a dedicated WAN aggregation device is needed to perform that functionality, okay, which can be an ASR or the other switches that are there. Out of these choices, considering the cost and performance criteria, the Cisco 735ME switch has selected to perform the WAN aggregation. The Cisco 3750 Metro switch has the following features or capabilities to adhere meet the requirements. Right? Hierarchical QoS, okay, quality of service, routing support, okay, supports those routers. Okay, these are mostly protocols. Right? Multi-site support and redundant power supply. Okay, so basically, what do you see here? Okay, these are just the models of switches and routers that you need for your WAN. Okay, so don't get be scared about what is all these numbers here. These are just the model of the switch that you use for your performance in your WAN. So medium, okay, so medium as discussed in chapter 2, okay, the medium remote site collapse the WAN edge and co-layer LAN functionality into a single switch to provide cost-effective to meet the budget need for the site's location. The remote medium site is connected to the main site location through metro service, and the recommended switches and routers are there that you can use for your route medium site. And small remote site, okay, the small remote site is connected to main site using a private lease line service. The WAN speed between the small route site and the main site location is assumed to be around 20 Mbps, and this service is provided by a traditional leased line. Since it is leased line circuit, WAN service such as Cisco, okay, or Metro 3450 switch could be used. Therefore, an integrated service router is needed to meet the requirements. Okay, so yeah, so you have whichever recommended switches and routers for a small. So basically, our center at Namaka would fit somewhere here. Okay, so when the campus opens, we might we would yeah we would go and see which router is being used there and which switch is being used there, right? So implementation of WAN reference design. Okay, the following section discusses the implementation details for the medium enterprise design profile. The major components of the implementation are the following. So you have WAN infrastructure design, routing, quality of service, resilience, and multicast. WAN infrastructure design, as explained in the design consideration in chapter 1, the medium enterprise design profile uses two different services to connect the route remote site location to the main site location. The large remote site and medium remote site would connect to main site using the metro ethernet service. The small remote site uses a leased line service to connect to the main site location. The large remote site, due to its size, is recommended to have 1 Gbps metro service to the main site, whereas a small remote site location is recommended to have at least 20 Mbps of bandwidth to main site. The following section provides the configuration details of all the WAN devices need to establish the WAN connectivity. Okay, so here it basically gives you configuration. Okay, so when uni opens, we are back in class, we might try. Okay, most of the technicians, what they do, Now, I have seen this for TFL. What they do is they have these already saved in their notepad. Okay, so you just copy, change the IP addresses, put it there, and then just run it. Okay, if you do not know, all these things are configuration for routers and switches. Okay, you need things to be configured like this, then only it will work. If it's not configured, okay, it won't. And mostly it is done with this command prompt. You just type in, try to go into the device first, right? And then from there you can do the configurations. Okay, lease line service. Okay, the WAN bandwidth requirement for a small remote site is assumed to be 20 Mbps. Okay, Cisco recommends that the small remote site connect to the main site using a private lease line service. The lease line service is more readily available for these types of locations, and the bandwidth is sufficient for the small remote site application requirements. To implement this design, a serial SPA is needed on the ASR 1006 WAN aggregation router at the main site, and the SPA needs to be enabled for T3, okay, tier 3 uh, interface type. The configuration below illustrates how to enable and configure the tier 3 interface. Okay, again, we have the configurations. Right, and then routing design. Okay, this section, okay, explains how routing is designed and implemented in the medium enterprise design profile. As indicated in the WAN design, transport design, the medium enterprise design profile has multiple transports: private WAN, internet, metro service, lease line services. The private network would provide access to reach other remote sites globally. Internet service would help the medium enterprise to reach internet, or metro lease line service would help to connect remote site location to the main site. To provide connectivity using this transport service, we have designed two distinct routing domains, external and internal. The external routing domain is where the medium enterprise would connect with external autonomous system, and the internal routing domain is where the entire routing domain is within single autonomous system. The following section discusses about the external routing domain and internal, right? So external routing domain, okay, is indicated above. The external routing domain would connect the different service providers, provide WAN and the internet service. This is applicable only when the WAN aggregation router 1, which provides both private WAN and the internet service, because it is the only router which interfaces with the external domain. The main design concentration for routing is for internet or the private WAN edge router are as follows. You can scale up to large number of routes, support for multiple homing, connect to different service providers, and ability to implement complex policies, have separate policies for incoming and outgoing traffic. And to meet the above requirements, the BGP design is chosen as the routing protocol of the following reasons. Okay, scalability. It's BGP is sorry, BGP is far superior when routing table entries is quite large. Okay, complex policies. IGP protocol is better in environments where the neighbors are trusted, whereas when dealing with the different service providers, complex policies are needed to deal with incoming and outgoing entries. BGP supports have different policies for incoming and outgoing prefix. Okay, BGP and IGP, those are protocols. Okay, yeah, broader gateway protocol, that is BGP, and then there you have a BGP design in the medium enterprise. Right, let's go to QoS. Okay, so quality of service is part of foundation service, which is very critical to the application performance. The traditional applications such as voice, video, and data, together with new applications such as broadcast, video, real-time video, video surveillance, and many other applications have all converged into IP networks. Moreover, each of these applications require different performance characteristics on the network. For example, data applications may need only high uh, throughput but are tolerant to delay and loss. Similarly, voice applications need constant low bandwidth and low delay performance. To cater to these performance characteristics, Cisco IOS have several robust QoS tools such as classification and marking, querying, QRED, policing, shaping, and other tools to affect the traffic characteristics, right? So what this is saying is, in one network, okay, you have so many things. Okay, you have servers, you might also uh, yeah, you have broadcast videos, real-time videos, video surveillance, all these things come into one. Okay, but all applications, they have different level of the accessibility or the requirements they want from the network, the bandwidth. So what this does is, if something they needs a higher bandwidth, okay, it'll cater them on the put them on the higher bit of that bandwidth. If somebody say telephone, they need a lower bandwidth, so they'll put it down there. What they'll do is try to optimize your bandwidth in such a way that all the applications, they work perfectly without putting pressure too much, without having too much latencies. Okay. Okay. So we will stop there because the um this one will just to cut off in 2 minutes. We'll just take a 5 minutes break, and then after that we will start with QoS implementation. Okay, so let's be back here in, say, by 10:44, right? And then we'll continue. Just click on the same link and you should be connected again. Right, so next is QoS implementation, right? So this section discusses how QoS is implemented in medium enterprise design profile. Explain As explained in the QoS design consideration, the main objective of the quality of service implementation is to ensure that the 12 class of LAN traffic is mapped into 4 classes of WAN traffic. Each class should have received the adequate bandwidth and duration congestion, and each class must receive the guaranteed minimum bandwidth. To accomplish this objective, the following methods are used to implement QoS policies. Basically, what it is saying is, in your when whatever you have, everything should work perfectly, right? So three layer hierarchical design. Okay, so this is needed when multiple sites need to share a common bandwidth, and each site needs dedicated bandwidth and querying within the reserved policy. Two-layer hierarchical design. Okay, this design is needed when the interface bandwidth is higher than the SLA bandwidth allocated by the service provider. For example, if the physical link is 100 Mbps, but the service provider has only allocated 50 Mbps. In this scenario, we need two policies. Okay, the first policy is which is parent policy, would shape the entire traffic to 50 Mbps, and then the child policy would queue and allocate bandwidth of each class. So I hope you have understood what it's saying there. Okay, sometimes what it is saying is if you have a line that is given, you have only 100 Mbps line that is given, but whatever you have in your infrastructure, it requires 100 Mbps, right? But allocation only you have is 50 Mbps. So in that case, you have to make two policies, okay? Parent policy and the child policy that will queue, okay? Which one will go when, so that they can allocate, use that 50 Mbps. That 100 is broken down into two, okay? Because that is your requirement. And then at one time, it can only cater for 50 Mbps. So what will it do? It will queue. Okay, this one go, this one go, this one go, this one go. That is how that'll make up that 100. A single layer design. If the interface bandwidth and the SLA bandwidth of the provider are equal, then we can use a single QoS policy to share the bandwidth among the classes of traffic, which is 4 in our design. Okay, this section describes the detailed implementation of QoS policies in various parts of the network. The devices that need the QoS configuration are as below. Okay, so those are some of the devices that need the configurations. Right, so QoS implementation and WAN aggregation router one. Okay, the WAN aggregation router one connects to two different providers. You have the private WAN network and the internet. It is assumed that the aggregated bandwidth is 100 Mbps that should be shared between both services. Okay, 50 Mbps is dedicated for private WAN and 50 Mbps is dedicated for internet traffic. As explained in the various section, we will implement this policy. A three-layer hierarchical QoS design needs to be used. So basically, this is, yeah, you have 100 Mbps, so 50-50. Okay, it's the private 50 Mbps private with four classes, and the internet has 50 M with internet with four classes. So here, to implement a three-layer hierarchical QoS policy on the WAN aggregation one router, a higher level parent policy is defined that would shape the aggregation WAN service to 100 Mbps. Then sub-parent policies are defined, which would further shape it into 50 Mbps. Within each of the sub-parent policies, there are four defined classes: real-time critical data, best effort, and something is there, okay? Some class there, yeah. So you have IE child policy, IE parent, and then you have parent policy, and then V child policy, WE policy, and so forth. So this becomes your hierarchical, okay, three-layer QoS policy. Okay, so step one, define parent policy. Okay, now this goes into configuration bit, how they configure it. Okay, I will try and find some good videos and put it on how they actually configure those routers and switches so that you get an idea. So this one you can read it on your own time, but I'll try to find a video that is appropriate for this. Okay, that will be easier for you to understand. Again, you have implementation of WAN aggregation router 1. These are the steps that are done, okay, on the router. Basically, these are codes, right? So that is what you do for them to implement that. And then QoS policy implementation for WAN aggregation router 2. QoS configuration at WAN aggregation router 2 is a more complex than QoS configuration of WAN aggregation router 1 because of the different speed connection to the router. It depicts the different types of WAN. That QoS policy between main site and medium remote site location. So a three-layer QoS design is needed between the main site and the large remote medium site location because there could be a couple of remote medium site location connected to a single metro link to the main site. This shows how this design looks like when there are more than one remote medium site. So you have 100 Mbps lines for these. Okay, here it comes to 1 Gbps. Okay, see the thing here is most of the things are of configuration, right? So these things need to be done when we have a actual router that is in when we are in the in campus. Okay, so then QoS policy between main site and small remote site location again gives you a, so the following is the QoS policy implementation steps between main site and small remote site. The actual WAN speed is 44 Mbps, however the SLA is assumed to be 20 Mbps. Therefore, a two-layer hierarchical QoS design is needed to implement the above policy. So, and then gives you the steps of what you have to do. And so forth for the large and the main site and medium and main site, small site and main site. Okay. So what I'll try to do is to make this part simple. I'll try and find videos where they do the actual the setup so that you can actually see and try and actually have a a feel of how things are done. Okay, then redundancy must be factored into the WAN design for a number of reasons. Since the WAN may span across several service provider networks, it is likely that network will be subjected to different kinds of failures occurring all the time. Some of the following failures can occur over a period of time. Okay, flaps, brownouts, fiber being cut, and device failures. The probability of these occurring over a short period of time is low, but the occurrence is highly likely over a long period of time. To meet these challenges, different kind of redundancy should be planned. The following are some of the ways to support redundancy. Okay, so you have QNS or SSO for networks that obtain 99.9999% of availability. Technologies such as NSF or SSO are needed. The NSF would route packets until the route convergence is complete, whereas SSO allows standby RP to take immediate control and maintain connectivity protocols. And then software usage upgrade, like ISSU, allows a software to be updated or modified while packet forwarding continues with minimal interruptions. And there you have as a channel load balancing. Enabling this feature provides link resiliency and load balancing of traffic. This feature is enabled to the WAN aggregation to device. Okay, yeah, link redundancies. You have a spare link. Okay, and then you have multicast. Okay, the main design consideration of the multicast are as follows. Okay, the number of groups supported by a WAN edge device. This is scalability factor of the WAN edge device. The platform chosen must support the number of required groups. The placement of the RP. There are a couple of options available with RP placements, which include any cast with static, any cast with auto RP, or any cast with PSR. Okay, multiple protocols. Okay, we have, and QoS policies must be configured for multiple traffic so that the traffic does not affect the unicast traffic. And then summary, okay, designing the WAN network aspect for the Cisco medium enterprise design profile interconnects the various uh, various LAN location as well as layers the foundation to provide safely and security operational efficiencies, virtual learning environments, and secure rooms, classrooms. Okay, so this chapter reviewed the WAN design models recommended by Cisco and where to apply these models within the various locations within a medium enterprise network. Key WAN design principles such as WAN aggregation platform selection, QoS, multicast and redundancy best practice are discussed for the entire medium enterprise design profile. Designing the WAN network of a medium enterprise using these recommendations and best practices will establish a network that is resilient in case of failure, scalable for future growth, simplified to deploy and manage, and cost effective to meet the budget needs of a medium enterprise. Right. So basically, this was today's lecture. And any questions, anyone? Yes, no? If no, then we will stop the class here. The next class will be now on Monday, okay? Next week. And I will send you the link for that. Meanwhile, try and finish off or try and at least attempt the tutorials for this, right? And don't be scared if you are not understanding anything. I know this is a new unit, a major something new that has come in. So we'll take things one at a time, and we'll finish this. Okay, don't worry. Right, so see you on next week Monday.
Okay, thank you,
Yes.
sir.
Thank you, sir.
Yes.